Hi everyone, and welcome back to ARTtech Seminar. Our next speaker is Tommi Toivonen from MeHackit, and Tommi is going to talk about live coding for musicians and educators, and a couple of live demos included also. Welcome, Tommi.
So, hi everyone, my name is Tommi Toivonen, and I'm from MeHackit. I'm going to tell you about live coding of music and how it is actually a really useful tool for programming, technology, education, and also for musicians. First, a little bit about myself. My title says artist/hacker. So I do all kinds of creative content for MeHackit's workshops for kids and youth, but I'm mainly a course and curriculum developer at the moment and working currently on the Sonic Pi music programming curriculum. I'm kind of an engineer, computer scientist converted into an artist. I play in 2 bands, mainly electronic music, and I've been involved with startups and game industry for the last 10 years, quite heavily. But how I actually got into the whole electronic music myself, I'm a musician, mainly. That's how I consider myself. So it was my passion for computers and music that got me this far here. So I've started very early on as a kid by playing with Commodore 64. Then I started programming my own little games and also did some music and tunes. My first bleeps were made with Commodore 64 Basic, if I recall correctly. And I never was quite interested in formal music training or classical instruments. But it was something like this screen here, that's Fast Tracker 2 from 90s, that really sparked hit the chord in me, to say. So that ignited the passion for me to learn more about music and compose my own music. So it was computers. So it was way before Logic, Ableton, Pro Tools, or any other digital workstation. You could do a lot with these trackers, and it's super cool to still see them actively used here at Assembly Music Demo Compose. And it's actually not so much different from the Sonic Pi live coding of music, which you'll see later in my presentation. So the outline for my presentation is, so if you only are here for the live coding of music, bear with me for the first 10 minutes. I'm going to tell you about MeHackit and our creative technology curriculum. And then we'll go through the basics of how you can program music with Sonic Pi, and hopefully I'll have time to show some more advanced examples as well. So, MeHackit. We are a Helsinki-based startup, 7 core team members at the moment. So we do creative technology education in schools here in Nordics. At the moment, we have 3 different school courses. Firstly, electronics and programming with Arduino, and visual arts and programming with processing. They are longer 38-hour courses for upper secondary schools here. And in addition, we also have a shorter 6-hour music and programming workshop for lower secondary schools. That is yläaste. So the 2 before that were for lukio. And all of them, they provide an entry-level introduction to programming. But they also cater for those who are on a more advanced level already. And we are currently teaching these workshops everywhere in Finland, and we've already been teaching one of our courses in Stockholm, Sweden. Over 80 schools in 3 years, which is pretty impressive. And the core of MeHackit comes from the maker culture. And that's deeply rooted also in the founding team. So in every course and workshop we have, there's a lot of creative tinkering involved and hacking in addition to programming. Here are some examples of what the kids have done with Arduino, for example. Is there audio coming in? I think there's supposed to be sound coming out as well. Cool. So there were a few of those examples, and we also teach visual arts with processing, and these are some of the works made by high school students as well. These are not the final projects, but part of when we do 2D transformations and simple graphics processing.
Drop the bass.
So let's hope in future some of those who have just learned a little bit about computer graphics and programming will attend assembly and do some demos. That would be so cool. But they were all high school kids from first or third grade in high school. And the song was also made by a high school student with Sonic Pi completely, which is super cool. Okay, so MeHackit courses, they're all taught in blended learning format, which basically means that there is always an instructor. We have a MOOC, an online learning platform for all our materials, but the real instructor, who is actually taught by us, will be present in the classroom and making sure that everybody makes progress in the end. And the courses, they are meant to be inspirational, evoke creative ideas, and teach you the basics of programming and the specific topic in the course, which can be electronics, visual arts, or music. Now, what is common with all these tools we use, Arduino, processing, and Sonic Pi? They're all open source and being actively developed currently. And they're really popular all around the world in the maker scene and also in the classrooms. And when the kids are done with the course, internet is full of tutorials and examples of what you can actually do with them. And I would say they are real tools, especially Arduino, used by professionals out there. Whether it's engineers, artists, or musicians, I would argue that you can do fully delivered work for, let's say, European Space Agency or Museum of Modern Arts with these tools. And this is quickly our instructors. This picture is from last year's yearly learning event for the new instructors. So we go into the woods and have fun for the weekend. We get to know Arduino, processing, and Sonic Pi and learn everything about them. And our team they're usually local university students from all around Finland who actually go to the schools to do the instruction work. So they are the heroes of MeHackit. And if you're interested in joining MeHackit team, please contact me later after the presentation. So, a few more things. We do teacher training, which has been in high demand lately, as teachers are kind of struggling at the moment in the classrooms of how to adapt programming and teaching of programming for the kids. And we also did a first test in a vocational school, which is ammattikoulu. That was a great success. They were really into what you can do with Arduino. It was sort of a hack fest. They were students of car mechanics, and they basically rigged their own cars with all kinds of sensors and lights, and it was an insanely cool show in the end. And we also do a lot of work with art museums such as Kiasma and Emma, and do every now and then creative hack art workshops for the kids. And Microbit is still there. If somebody here doesn't know what Microbit is, it was launched, I think, last year, the year before that, run by BBC. So they provided this tiny, tiny little computer for all the kids in UK, for the lower secondary school kids. So like 500,000 units, and they are going to launch in Finland soon, and we are a partner with them as well. Shortly, our materials, they're all open source Creative Commons, and you can find them online at learn.mehackit.org. So please go check it out. And especially the contents of this workshop, Sonic Pi, you can find it at sonic-pi.mehackit.org. So before we go to the music coding, to summarize goals of Me Hack It. So with our courses, we want to give the youth the opportunity to build the technology themselves and really get inspired by this process. And everybody should at least have that opportunity so they won't feel left out in the world of technology. And that will also hopefully remove some of the inequality and anxiety related to the current technology advancements. And that's about it. So we want to offer the positive experience for them so it won't be that hard, or the threshold of doing coding once you've done even something and succeeded in is so much lower. This is a cool thing. We recently got our kits. They will be for sale later this year, and we are delivering them to the schools for the next Arduino courses. It has an Arduino clone inside, and the best set of sensors and gadgets you can imagine to build your own robot cars, for example. All right, so let's get to Sonic Pi then. Sonic Pi, first, it's a coding environment for music created by a guy called Sam Aaron in Cambridge University in UK. It was initially made a few years ago for Raspberry Pi, but luckily now it has found its way also for Windows and Linux and Mac, so we can all enjoy it. But basically, with Sonic Pi, you can write lines of code that are translated into sounds and music. All right, so then I'll need to switch my clumsy switch. Sonic Pi here. Here we go, finally. So this is the basic interface of Sonic Pi. This is the editor, the large screen you see here, and there are only few buttons up there. There is run, stop, and record. So run executes the code, stop stops all the audio, and with this you can also record the sounds as WAV files, so if you want to make a ringtone or a track for yourself, and then you can save and load the tracks. The other stuff here is you have a scope which will visualize the sound that is being played. It's a good tool to learn about synthesis. And then you have a log here that displays events that are happening in Sonic Pi while it's playing the music. OK, let's try our first equivalent of Hello World with Sonic Pi. So I can write play, and let's try play, for example, 60. Can you hear anything? Yes. So that is a beep. So you can just write play and any number, and it plays a sound. What if I type 61? Oh, it gets higher, even higher. And if I try to put like 59, you get lower pitches. So these numbers are actually notes. After some of you might have heard of MIDI, which is a common protocol used in music production. So with MIDI, you have a list of numbers here, and they are all translated into keys, let's say from a piano keyboard. You can use numbers from 0 to 127, which all translate to the keys of a keyboard. Well, why use these numbers then, if you know music already? Well, for example, kids who don't know about music theory, they don't know about C, D, or B or F sharp, or G flat. They are really useful. So you can just type numbers. Let's type another number. Oh, it's in harmony now. And you can type a third number to play a third note. So you suddenly made a chord. But if we know music, we can also translate this to notation. Sonic Pi understands this type of notation. You can write comma and the letter of the note, and then a number. A number here indicates the octave of this note. So for example, you know piano has 7 octaves, usually a grand piano. So fourth means like it's the middle octave, middle C of a piano. And then we can type in E. Let's try G. Now we actually played the same, exactly same notes. So 60 is the same as the middle C of a piano. Okay, so now they're all playing at the same time. How do we start creating rhythms and melodies out of this? We could just, write as many plays here, and in the end it would probably sound awful, them all playing at the same time. So there is a specific command called sleep, which tells the program to wait before executing the next line of code. So now I can play those notes one after another. And what's cool, I can actually change these numbers. Let's put 0.5 here, 0.5. Let's play 2 here. So you know that it's now when I increase the number, it's waiting a longer time. And when I actually halve the number, it's much more faster. So the sleep 1 doesn't mean like wait for 1 second, but in music, you always count beats. So it's like 1, 2, 3, 4. And Sonic Pi has a clock inside that keeps everything in time. So when you write more complex songs with Sonic Pi, everything is synced and they stay in time all the time. So there is a master clock that can be set with a command called use_BPM. The normal tempo when you don't set it, it's 60, so it's relatively slow. So we can write here 130. We can try like 600. You can imagine the kids instantly write like 1 million or so in that. And then it probably can crash or something. Okay, let's go with 130. And now we have created a basic melody here. I'll go with the minor key, so I'll flat the E1. So it's a bit more mysterious for me. I don't like too bright major sounds. And now if I want to, for example, loop this, I want to repeat this section, I can write 4 dot times and then do and end here. So these are the same as the brackets in most coding languages. This is basically Ruby, but with additional layers and commands that you can use to create music. Sonic Pi understands most of what Ruby does, so you can write whatever file parsers and all kinds of weird stuff or network stuff with Sonic Pi as well. So now it's looping that for 4 times. And I forgot actually, after the last play, I forgot to add another sleep. So this note and this note were playing at the same time. So now it should be working. Like this. Okay, then I'm going to introduce a new command. Before that, there are these kind of puskuri. They're called buffers. They're like the tabs of your browser. So you can keep different code sketches in them. And when you click the run button, you only run the currently active buffer. So I can use this another buffer to test different things. I can, for example, use a command called sample, which provides a nice list of all the samples that come with Sonic Pi. So it has a quite extensive library of different sound. Let's play a few of them. Some of them are not too loud, so it might be hard to hear them. So you have ambient cinematic sounds. We have bass sounds like this. And let's see. You have drum sounds. So if you want to make a rock drum track, you can do it. You have the cowbell, of course. And even some really, really ridiculous sounds like burp. Or then you have the crow. And you can do a lot of different things with the sample. When you open the help, you get a manual for all the commands, so you can see that there's so many parameters and options you can do with this command. But few of the simplest ones, they're like amp, which controls the volume. So if I put 3 here, it's 3 times as loud. or 0.5, so it's half of the normal volume. And then you have, for example, rate, which controls the playback rate. So 1 is normal, 0.5 is like half speed, or 2 is like double. And you can also add negative numbers to play it as a reverse sample. Super fun. Okay, let's create a drum beat quickly with this. So we can add BD house, which is like a cool kick drum. And then we can sleep for 1 beat, and then let's play a snare. Okay. So now we have a drum beat, and we need to add it to our melody. So I'm just cutting and pasting it to this buffer 0. So it's not quite working as I want it to work, because I want them to play at the very same time. Now it currently just runs linearly all these lines of code, and then repeats 4 times whatever is happening inside here. So there are a few ways to get around this, but this is a cool thing, I think, with Sonic Pi, that when you teach this to kids, they normally, with programming, they don't run into the problem of how to run things simultaneously or do concurrency. But with Sonic Pi, you have to face that quite early, and usually they get it instantly. So there are a few things you can do. One is like a command called in_thread, which allows you to separate a thread that will be run independently, but at the same time, when this thread is being run, Sonic Pi also executes this loop here. That's one way to do, and you can also do arrangements with this kind of technique. So you can write here like 4 times do and end. But usually when we are in the classroom, we just want to sort of jam around, have fun, and keep the music playing. Like that's a contemporary way of doing music nowadays. When you imagine like devices that Ableton or Native Instrument creates for us, they're all like loop-based, they're looping all the time, and you tweak the knobs and have fun. So with Sonic Pi, you can do the same. So there is a command called live loop. For the live loop, you have to give a name. So you add a colon and then give it any name you want, like my drums, and then add the do. And we have to remove the other end here. So now that drum loop is playing constantly. It never stops until I actually press the stop button or write a command called stop here. So now we can start having fun by actually creating another live loop for this synth melody as well. So now I'm live coding. I'm changing the sounds on fly and try different things here. I can change the tone of the synthesizer with a command called use synth. Let's try something else, like a basic saw wave. All right, here it is. Now if I want to create, let's say, faster type EDM bass line, like 1/16th note, I can just change this live loop, how it works, and put 0.25 here. So it's like a 16th note sleep. Now, and you notice that it's playing on top of the note that is being re-triggered, so it's not a bass line I would like to hear. We can use a command called release to make the note shorter. So now it's playing all the time 1 beat, each note. So if I put here 0.25, now it's playing like a monophonic synthesizer. And then I can add some effects here. Let's, for example, add a little bit of distortion to this. You can use this kind of wrappers like with_effects to add distortion to certain parts of the code. So now it will affect these sounds in here. And you can find some really cool stuff with all these synthesizers, like cutoff. So most of you might know if you have produced music. So it's a low-pass filter, and it controls the cutoff point. So it's removing the higher frequencies of the sound. Let's put 60 there, or 50, or 40. All right. And now we can use all cool numeric commands that SonicPy has. For example, if we want to make a sort of a filter sweep that is modulating all the time, going up and down, we can use a command called range. So it will give you a list of numbers between minimum and maximum. So let's say the filter will start from 40 and go up until 100 in steps of 1. Or let's put 0.5 here, so in steps of half. So this will return a list, and then we can use a special command called tick to go through the list. So with every pass of the live loop, because this one is looping here, it's every time refreshing a new number for the cutoff. If I want to make the sweep faster, I can put 1 here. And then I can even add some reverb to the sounds. I can wrap the live loop in a reverb. And now I can start live coding. I can instantly create, I'll just close the help window so we have more space here. But you noticed what happened, like the filter sweeps up, but then it just drops down like this. We can actually avoid that. There is a command called mirror, which will double the list, so it will create another list after the first number list. So it will first go up, and mirror creates a list with reverse order. So the numbers are descending from 130 to 40. So it's like, boop, a ramp like this. So if we add a command mirror to this line, and with a special command when I'm live coding, I can use a command called sync to sync the newly created live loop hi-hats to, for example, my drums here. I can just copy and paste that. And then I can write my hi-hat loop in this one. Not triggering, wondering, or is it triggering? Let's try. What's wrong with that? Probably some error in my code. Now what I can do actually, I can randomize stuff. And this is where it starts to get really interesting. For example, the volume of the hi-hat. A drummer never plays like that, a steady beat. So you can actually randomize the amplitude with a command called rrand. So inside that command, you write the minimum value of the volume and the maximum value. So now it's much more dynamic. And then I can start writing some different loops here. Let's try the sync again. Let's create another loop here. was wondering, there's something with the sync. So now we have a loop playing, and this beat stretch command forces the loop to be a measure of exactly 4 beats. And then I can start mangling with this beat. I can slice it in random order. I can define how many slices I want out of that loop. Let's say I want 16 slices, and then I can add a command called slice, and then a command called pick to pick any out of those 16 slices. So what this does is actually it sort of randomizes the flow of the loop aim and sample. So if we mute the bass track, you can always use a hashtag command here to mute sounds in the code. So that's how we go. And if you want to create a funky hi-hat, we can randomize the sleep time. We can give it a determined set of values like 16th note sleep time or 8th note. Like, let's do like this. And then use a command called choose. So we just create a table here. And now the choose command here will pick any of those 3 values inside the table. You can do same with the kick drum as well. So if we want to create a really weird dynamic beats, so we can add something like this. Here, let's see how it sounds. So now we have a weird ass beat going on. We could even do same for this one here. Oh yeah. And let's add some long reverb to this sound. See how it actually affects the sound. So you can use an option called room to determine how long the reverb sound will be. So for those who don't know, reverb effect actually simulates the physical surroundings of us. So you can simulate the sound like being in a big hall, like this messukeskus here. So now you should probably don't hear, I don't have such a good monitoring here. You should hear that the sound is being transformed into a different space. Kiitos. And we can also do some cool stuff for the sample stuff. We can randomize. Let's see what samples we have. I need the list. BD fats. Let's put some. Let's put some three samples in that one. Like that. So now, every time the sample command is being run, it will choose one of those 3 samples. And you can create a really elaborate list here. Like, let's do some more stuff there. Quite out of hand. And then we can go back to the bass line. Let's make it as funky as well. I don't know what's becoming of this, but we'll see. And you can also use a list like that in the notes. So when here is like play C2, it's playing the constantly same note. Like this. But you can also create a pattern of notes that is being played like this. So now it's playing, it's like a pattern sequencer of notes. So it's playing C2, 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 and then C sharp. And we could create a really much more interesting rhythm with this one. Let's try. And we can also use conditionals. For example, if we want to throw a dice, every time the live loop hi-hat is running, first thing we could do in a little bit like, let's throw a dice, 6-way dice. We can use a command called 1_in and then write 6 here. So it gives only true statement if the dice number is 6. And then we can do a basic conditional statement like if dice is 6, do this or else do that. So here. And we can write a different drum sample here. Let's use, for example, drum cymbal pedal. And we can actually remove the sleep from here and put it outside the conditional statement. And what's cool that we can actually transpose the melody on fly. We can add a number here, like if we want to transpose it 1 octave higher, we can put plus 12 here. And you could work out some kind of a breakdown by removing some of the samples and I'm kind of slowing my commenting today, so it's not like fast EDM guy, but slowly evolving. And here we go again. Okay, but this is a short example of what you can do in a few minutes with SonicPy. And usually in the classrooms, all the kids, the workshop is like 5 to 6 hours. But the kids actually get this far. So from without knowing anything, they create their own live loops, start jamming with the music. They do the live coding with their headsets on and they change the values. They can hear instantly the feedback of what changing a value in the code means in the music or in the audio. And let's go back to the slides for a second. So some of the things you learn during this kind of workshop with SonicPy, I think most of these happened. So you definitely learn how to write programming syntax and how to run your program. You get that concept. And you definitely face errors. I probably didn't do an error, but when you write wrong, let's say you write misspell play or sleep, the SonicPy IDE will give you an error and point out to that place that you have to fix this. So they will have to fix stuff and iterate as well. So concurrency, like I said, when you go from the linear doing of code to actually doing stuff simultaneously with live loops. And you face conditional statements and randomization and data structures in the forms of the tables if you, for example, create a node sequencer or you create a table from where you actually pick some of the sleep values for the live loops, for example. And the most importantly, that programming can be a really, really creative skill. And why you should teach programming with SonicPy? Well, probably most of you probably going to agree with all of this stuff here. So music is awesome. It's a good hobby, even if you don't do it for a living. But with this kind of environment, it's open, it's free for everyone to use. I don't see any reason why teachers shouldn't at least try this in the classrooms. Whether you're teaching ICT or music or maths, it's all there. So it really crosses the boundaries of just programming. So it's both arts and programming at the same time. And Sam Aaron here, if you can pump up the volume a bit, there is a quote here.
I believe that code is one of the most creative things we have today, and it's super exciting, and I really want to try and get the message across. But it's really hard to go into classrooms or into children and say, hey, you need to learn to code because it's good for sorting things. I think it's much more interesting to take it and say, hey, you can make some music or some fat beats, and that will engage them in a much more interesting way.
I think it's a good point that it might be more interesting to create fat beats instead of sorting a table, which is important, although, but for the introduction to programming, I think he has good thinking there. Okay, and Sonic Pi, as I'm a musician, I use it in my studio as well. There is a Windows version as well if you're running on Windows. So as a performing tool, I've been using it in different events, not with my band yet, but I plan to do so at some time in the near future. But it kinda, live coding has been there for over 10 years. People have done amazing stuff with Super Collider and so, but it's still a novelty thing for most, and it's not used a lot on the stages at the moment. So it's a really interesting way of performing music, and I think that it can remove some of that problem that some of the audience members don't know what the artist is doing when he's there or she's there behind the laptop. But now, especially if you project the code on the screen, you get total transparency of what's happening with the music. And it's a great tool for generative music. We didn't get to go there as far as I would want. Maybe I can show one example soon. And the new version has a full MIDI and OSC support. So if you want to run your external synthesizers or use Ableton or Pro Tools with Sonic Pi, you can use these live loops to send MIDI to any device you have or any software you have. And there are so many cool things you can do with your digital audio workstation easily. I will show you a few things. Let's see. This is a funny thing. I have a folder. Here is a file path. So a folder that has like 30 or 50 songs. And this mashup is picking random snippets of all of those audio files in the folder and creates sort of a remix out of those. Let's see. It's some super neuro funk. I don't know, but you would have to have an insane amount of, put insane amount of work hours in Ableton or some other software to do that. And one cool thing is that you can use the MIDI command, like in this sketch. So I'm sending it actually to Ableton here. So let's see if it works. Oops. No, not at the moment. I'll actually restart Sonic Pi. That might be the root cause of this. So let's do it. But it's really interesting when you can use your professional sounds and libraries with Sonic Pi. Okay, now it's sending this kind of jazzy drumming and progression. This is fully generative, and all the instruments are in Ableton. So I have my piano sampler here, the Hammersmith grand piano, and then I have a garage kit from Contact. And now I can actually change the values here. I can change the scale I'm playing. Let's say I'm going to play major pentatonic scale. I want to change the notes I'm playing. I want to go to C sharp 3, and then I go to A sharp 3. So I can improvise. I'm a full jazz guy now. That's fun. And here is like another generative MIDI example. This is like a town in a role-playing game where you meet some characters. But the live loops are just sending random MIDI to Ableton, and So you don't have to settle in with just using Sonic Pi sounds. You can extend from that. So I'm out of time. Any questions at the moment? So if you want to shout out later to me, go to sonic-pi.mihakit.org and check through the MiHakit materials. If you're a teacher, you got interested into this, please stay in touch. You can send me an email to tommi@mihakit.org. Thank you.